in all the possible ways that we've learned how to do up to this point. So here's the function, here's my vertical line, here's the x-axis. So we're either going to draw a vertical rectangle. So we go here from 0 to 4, and the y-axis goes from 0 to 2 as far as the limits. And if we draw in a horizontal rectangle like that, okay. So we're actually going to calculate numbers this time for every one of them. So the first thing is to find the volume by rotating the area around the x-axis using the disk method, which will be the vertical rectangle, and then, or using the shell method, which is the horizontal rectangle. So you'll actually have to integrate both with respect to x and with respect to y. So if you had your nice cheat sheet, what you would find out, I'm just going to give you the equations and then you can go from there. So if you have a horizontal axis of rotation, which is what we have in this case, for the disk method, the equation is the volume is equal to pi times the integral from a to b of capital R of x squared dx. And if you use the shell method, the volume is equal to 2 pi times the integral from c to d of p of y times h of y times dy. So you'll have to, for the function that defines the top of the curve here is either y equals the square root of x, or it's x equals y squared, whichever one you need to use. So this is f of y is y squared. F of x equals x square root of x. So I'm going to give you like a 5-minute start, and you can the next page rotates around the y-axis using the washer method and the shell method. The third page rotates around a line x equals 6, which is another vertical. It's a vertical axis. So the second problem and the third problem are both vertical axes. The first and the last problem are horizontal axes. But when we get to where the axis of rotation is something other than the x or y axis, you'll have to do something different. So I'll let you get to that point. And I want to go to my office here. Let me just pause my recording. So since there won't be any noise, you'll see that I don't know why. I guess that's interesting. Okay, so the first problem. Let me move these apart. So the limits are, we're integrating with respect to x. So this is the vertical rectangle. And so we're integrating with respect to x from 0 to 4. And the radius is the outside part of the rectangle. So in this case, r of x is equal to the function. So it's equal to the square root of x. And you square that, and you multiply by dy. Okay, so that's your first integral, which is pretty easy. Now, with the shell method, your limits of integration are in the y direction. So we go from 0 here to 2. So it's integral from 0 to 2. P of when you do it around the axis, P of y is just y. So that's P of y. And h of y is just this value minus that value. well, this value is 0, but I'll show it in there. But you have to do it as a function of y. So it's going to be equal to the square root of y minus 0 times dy. Okay. So those are the two integrals, and they should give you the same answer when you should get 8 pi. There were cases where I didn't get the same answer, which I realized then I didn't do one of them right, and then I had to go back and figure out where I went wrong. So while you're doing that, I'm going to write down the numbers from 1 to 29. Here. Do our experiment. Okay, so I'm going to ask the people that pick numbers. What I'm going to do is I'm going to just take my cursor down, and when I get to your number, say yes. Okay. How many people said yes for 1? Oh, it can't be 1 because you didn't get no. The only people that took a thing, right? So you guys did get 1s, right? Okay. Okay, so we got 3 of those. 2. Oh, keep going here. Oh, you had 2 also? Okay. Oh, who had 4? Oh, you had 4. Okay. I heard it come from that direction. Okay, so it worked again. So these two, you see that 1 and 2 were multiples. Okay, so we'll do it again. We'll start from the other side of the room. Again, you pick a number out of the pause. Okay, so for the second problem, you've got so for a vertical, both of these are vertical axis of rotation. And so for the washer method, so that's going to be, if you think about the washer method, that's going to be this thing going around there. So it's going to be with respect to y. So it's going to be a washer method. So okay, volume is equal to pi times the integral from c to d of r of y squared minus small r of y squared times dy. And the shell method, so look at the shell. This is the shell. It goes around like that, creates a shell. And in the case there, we're integrating with respect to x. So it's going to be the volume is equal to 2 pi times the integral from a to b of p of x times h of x times dx. And you can see they're exactly opposite what we did over here. Here we had r of x squared from a to b. Here we had r of y squared from c to d, but we subtracted the inner radius. And then this one, we're using p of x, h of x, and dx from a to b. So it makes sense because we're doing exactly the opposite. Okay, so let's think what we got here. So if we go back to the washer method, this is, and what are we integrating with respect to? Y. So the Is that right? Did I do that right? Washer method. Oh yeah. So so r of y is, in this case, is equal to 4. Okay, because it's x is, well, what the line is that represents the top of this rectangle is the line x equals 4. So f of y is equal to, f of x is equal to x equals 4. Okay, so that's 4. And small r of x, small r of y. So let me do this again. So capital R of y is x equals 4. And because this is a function of y, which turns out to be just a constant. And then the small r of y is going to be equal to y squared. So the equation, the function is x equals y squared. That gets a little confusing. So anyway, that's so the final integral you should be doing here is pi times the integral from 0 to 2 of 4 squared minus y squared squared times dy. Now down this one, you got 2 pi times the integral from 0 to 4. P of x is x, and h of x is the, so we're doing the shell method. So this is the height. As a function of x, it's equal to the square root of x, and the inside is 0. So let's do that. So it's going to be the square root of x minus 0 times dx. Something's wrong. What am I doing wrong here? I think. Did I do this one wrong? Should I? Let's see. H of y. So that actually should be y squared, shouldn't it? Did I do that wrong? Hold on. 128 pi over 3. Which one? The first one or the second one?
The second one. I think it's supposed to be 128 pi.
Oh, for 5. I might have to go to my office and look at my solution. I may have typed that wrong. So, yeah, this actually should be y squared, shouldn't it?
Okay, so like how you said this part was the top of it, like.
Yeah, right.
The,
that was x equals 4.
So that's also the top of it for the shell. So that would be the most positive for it.
That's the limit, yeah. So for the shell method, it goes from 0. That top part here is the, for the shell, is the limits. For the washer, it's the function that's limiting that.
But when we're trying to find like most positive minus least positive, what way do we look at it?
Well, for this, yeah, let's go back to this problem here. So when we have the shell method there, this is the shell. This horizontal one is the shell. And so this is the most positive. That's x equals 4. And here, the most negative is x equals y squared. So that's why I did that wrong there. Okay. Now on the next one, let me just put this in between. I'm trying to do too many things at one time. It's like that thing on being awkward, right? We're not good at doing 2 things at one time. So I'm trying to do my experiment and do this at the same time. Okay. Whereas here, the shell method, this is the shell part. And so this is the upper part of the curve. And so the most positive part is, and we're looking for the function as a function of x. So this is a function of x as a square root of y. So that's the most positive part. The most negative part is the line y equals 0.
So for the first equation, should h of y be y squared minus 0 or minus 4?
Oh, yeah, that's true. Okay, let me think about that. So for this one, we're talking about the shell method. So it should be, no,
Which rectangle is the shell method?
For the first part, yeah. For this is the first one for the shell method. Is that right? Yeah. So this is wrong again. This should be yeah. Is that right? That's the most positive. X equals 4. The most negative is x equals y squared. Yeah, and the radius. Okay, let me go get my solution so I don't mess that up again. Yep.
For the shell method around the horizontal axis,
Yeah.
wouldn't it just be y squared minus 0 because you're making that shell over and over again?
No, because we're not making that shell over and over again. We're making stacked shells. So the right hand, the more positive side of the shell, the width of the shell is going to be x equals 4, and the inner part of the inner part that defines the inner length of the shell is going to be the square root curve, and that changes. So the inside radius changes, not the radius, but the inside dimension changes. The outside, the one that's more positive, doesn't change. And the reason I realized that was when I was trying to convince you that we should be able to look between these two and see some kind of relationship. So what you can see is here, when I integrate with respect to y, here I had 4, here I have 4 squared, here I have y squared, here I have y squared squared. So that makes sense. And then from this perspective, I have square root of x minus 0 minus 0. So those look consistent now, and therefore I think that's right. But let me just run over to get my solution, and that way I don't make any more mistakes like that while I'm trying to do two things at one time. Okay, let me just check to make sure where's my solution here? Make sure I wrote these things down right. Yeah, I mean, if you probably didn't get the same right answer, you didn't get the same answer in the first one because they're probably, yeah. So this is now correct. It's both. So this one's correct now. It's 4 minus y squared. Okay, so what time do we have here? 8:43. Okay, so let's move on to, you can finish the calculations later, but let's think about the third problem. And the third problem says, what does it say? Find the volume by rotating the area around the line x equals 6. And what you have to think about is, let me get my picture and bring it over. So I'm not going to give you the answer yet, but I'm going to let you think about it. So is x equals 6 a vertical line or a horizontal line? Okay, so we should use whatever we found in the previous one, part 2, to use in part 3. The question is, how does it affect these values? It's still going to have, so this is part 3, it's still going to be the volume is equal to pi times the integral. The limits will still be the same. What will change is r of y and capital R of y and small r of y. So think about how rotating, what we're doing there is we're rotating around a line here, x equals 6. So before, the radiuses were from the y-axis to here and to there. In this case, the radiuses are going to be from here to there, capital R of y. So while you're trying to figure that one out for the first part, we'll do our experiment again here. So, I just told you not to multitask, but I'm doing it again anyway. So let's go back here and try this out. I got to find my numbers. There they are. So they're clean. Okay. So again, for the people who participated the second time, when I get to your number, say yes. Okay. 12, two 12s, okay.
I'm sorry, I wasn't paying attention. I had number 3.
Oh, so just one 12, huh? Okay. You had a what? 6? Oh, sorry. Anybody else got any numbers in here? Maybe it'd be easier to just go through here and just, okay. Let me just do it again. So let me clean them off. It might be better just to ask everybody individually. Okay, so
I had
22.
22.
Okay. Elias, 12. Okay. 17. Set 3. 6. Okay. 22. Oh, I already got to you that one time. I forgot to erase that, right? Nobody else has 22. Oh, somebody did have 22. Oh, okay. 8. 16. Okay. 12. 17. 28. 5. Maya, what'd you have? 28. Wow, that's pretty cool. So, so how many we had? Four that had 2. That's pretty cool. So 4 out of 4 times it's worked so far. Woo-hoo. Okay, back to this problem.
So does it not matter if it means an axis or a line, just the way
So that's what you should get. So in the original one we had y squared, which was the inside radius. Now the inside radius is 6 minus y squared. So that's now the outside radius. The inside radius. Where am I doing here? This is the inside radius. So when we move the axis to the other side over here, the inside radius becomes the outside radius, and the outside radius becomes the inside radius. So now this is the outside radius because it's from x equals 6 to the curve. So it's 6 minus y squared. And you square that because we're using the washer method. And then the inside radius is actually fixed. It's going to be 6 minus 4. So again, I took this, which was the outside radius over here, now became the inside radius, but it's 6 minus 4, it's not 4. So 6 minus 4 is 2. Okay, so that would be the integral for using the washer method. And use it for the disk method, that's a lot easier. I mean the shell method. So you get 2 pi times the integral from, again, the limits don't change, 0 to 4. So it's still a shell because it's still a vertical axis. The thing that changes, the boundaries of the rectangle don't change. What changes is the radius, this p of x. And so all you have instead of x is you have 6 minus x times h of y, h of x, which is the square root of x, minus 0 times dx. Make sure I did that right. So we got 6 minus squared. Yep. Looks good. And the second one looks good. Okay. So those are the 2 equations. It's always much easier to switch the axis of rotation with the shell method because it's always just the first term. The second term always stays the same. Whereas with the washer method or the disk method, the inside radius, well, as long as I switched it over to the other side, if I actually wanted to rotate around x equals -2, then it would be different. But then you'd have to add, you'd have x plus 2 instead of 6 minus x. But okay, so why don't you think about, now that we've done that one, what you might want to do is to take your first problem. So the last problem is a horizontal axis of rotation, but it's around y equals 5 instead of around. So let me just move these things out of the way. So the last problem, okay. Let me just pull this down a little bit. So what we're doing now is we're rotating around this line, y equals 5. So here's the equations that we used for around the axes, the x and y axis. Now we got to see how those are affected by this change. So this was around the x-axis, so that's y equals 0 or x-axis. What we're not doing now is we want to do around y equals 5 and think about how that would change and then do the same thing down here. Again, this is around y equals 0 or the x-axis. So if we want to do around y equals 5, how would that change the equation? And I just told you that the shell methods is easy, right? So we should be able to do that one pretty easily. The disk method actually becomes a washer now, because if I rotate around the line y equals 5, this is the outside radius and this is the inside radius. But you have to do it with respect to the horizontal axis and not with respect to the x-axis. So you gotta do something 5 minus something, right? Let me make sure I didn't do any typos on the other ones as far as the right answers are concerned. 192 pi over 5, yep, okay. That's right. And 136 pi over 3, yep, that's correct. So the easy one, as I said here, is this one. All you do is you take 5 minus y, and then 4 minus y squared dy. So the shell method's a piece of cake when it comes to doing around another axis. This one's a little more difficult. You still have the same limits of integration. But let's draw so this is the inside radius, so that's r, and it's a function of x. So using the shell method, wait a second, using the washer method around y equals 5, it's going to go this way, so it's going to be a washer. So that's the inside radius, and this is the outside radius. So the outside radius is a constant. It's going to be 5. So r of x equals 5. So it's going to be 5 squared. And the inside radius, which we're going to subtract, squared, it's going to be 5 minus the square root of x squared. Make sure I did that right too. So it's 5 squared minus the quantity 5 minus the square root of x, quantity squared dx from 0 to 4. Yep, that's right. So what I would suggest, when you go to study session and you work on these problems, not only make sure that you get the right answer so when you hand it in you get credit, but also if you're confused about why I used certain things, talk to your classmates and say, can you explain this to me, because I still don't get it. Hopefully there's at least one of you that gets it. Does anybody have any questions about this right now while I'm... So at 9 o'clock, you can pack up. Remember to turn in the previous assignments that we've done on the in-class stuff. So turn those in before you leave, and I'll hand them back to you tomorrow. Yep.
Is it this stuff?
Yeah, there's that, and then there's another one.
There's another one.
Yeah, there was the one with the straight line stuff.
I think I know what you're talking
Yeah, it's this one right here. So it's this one here, and which had all the straight line things that we did, different methods, and this one's the other one. Oh, sorry. Put that.